Okay, here's a video explanation of the handout that I left just in case you need it. So we have 4 rules in this section. The first one says that you can do these kinds of problems that have both a root and a power in either order that you want to. Well, what does that mean? It kind of means that you could take something like the square root of 4 to the third, and you can also treat it as the square root of 4 to the third. And sometimes one of those feels easier to do than the other, even though they actually have the same answer. So we could take 4 to the third, but that's a little harder to do in our head, 4 times 4 times 4. But we could do that and then take the square root. Or we can do it the other way, and we could take the square root of 4, that's 2, and 2 to the third is 8. So that answer is 8, and it turns out that's the answer both ways. It's just that one way is easy to do in your head, and the other way is a little harder to do in your head. So you can do it whichever way feels easiest to you. This rule says that roots can be written as fractions. So sometimes we want to make it a little more complicated, but also fractional powers can be written as roots. So x to the 1/3 is the same as the cubed root of x. And the 4th root of m is the same as m to the 1/4. It just goes in the bottom. This rule tells us that we can put this idea together with powers. So if we go back up to this little example that we did right here, and we take that square root of 4 to the third, another way to write that is 4 to the 3/2. The power goes in the numerator, and the root goes in the denominator. So in this example, when they gave us a to the mk, that means a to the m, power in the numerator, root in the denominator. And this is a reiteration of the rule that's already written up here, that you can do them in whichever order makes the most sense to you. This rule I think we've seen before in Algebra 1, but it never hurts to have a reminder. A negative exponent tells us that this whole thing is on the wrong side of the fraction bar. So if I have x to the -2nd, that could be better written as 1 over x to the 2nd. Negative exponents aren't in simplest form, so we really should rewrite them with a positive. If it was already on the bottom, 1 over x to the -2nd, that means it's supposed to be on the top. So a negative exponent tells us we're on the wrong side of the fraction bar. So let's put these together, and we take these rules that we already have. So this is telling me I want the cubed root of 25c to the 4th to the 2nd. Okay, the cubed root of 25 is not really coming to me at the moment. I don't know about you. 25 squared, frankly, is also not something I can do in my head, but I can do it either way that I like. So I'm going to get my calculator out, and I can do the cubed root of 25 first, or I can do the squared part first. So I'm going to make a choice. I'm going to go 25 squared. And then that answer, I want to take the cubed root of, here's my cubed root button. So cubed root of that 625 that I just got tells me that that part of the answer doesn't actually simplify to anything pretty. So if it doesn't simplify to anything pretty, a nice pretty number, then what we're going to do is just leave it the way it is. So we're going to leave that in there. We still have that 25 squared cubed root. What about this part? Can we simplify that at all? We can do either one we want first, remember. So I can do c to the 4th to the 2nd, gives me c to the 8th, and then take the cubed root of that. The cubed root of c to the 8th, well, I get 2 pairs, so those can come out, and then 2 that have to stay in. So this goes right here. That's still... No, we did the 2 to the 2nd. Okay, so we can do it this way. You can also do it the other way. You could do the cubed root of c to the 4th, and you'd get 1c on the outside, 1c on the inside, and then you'd square it, and you'd end up with this. So either way, we can do it, whichever way makes us the happiest. 8 to the 1/3 can also be written as cubed root of 8. That's that second rule, that fractional exponents are the same as roots. Here we combine the two ideas, and so we can take that x, and it could be rewritten as Remember, denominator is your root, numerator is your power, so I can rewrite it in radical notation. So this is in exponential notation, radical notation. So it's just two different ways of writing it, and one might be easier for one purpose and one might be easier for another. This one's a little more complicated version. I can write x to the 2/5 power root, y to the 3/5, again, here's power root, and then z to the 1/5 because it was just to the first and it had the 5th root taken. So radical notation, exponential notation. Negative exponents tell me that this is on the wrong side of the fraction bar, so I move the whole thing to the bottom. This is telling me that this whole thing is on the wrong side of the fraction bar. So I move it, but also I still have this, and I could rewrite it as cubed root of m. So two alternate kind of correct answers to this one, depending what I'm asked for. This is on the wrong side of the fraction bar, so I'm going to move it up to the top. And I can also rewrite it as a square root. I don't need the little 2 this time. Remember, we assume the 2 if we're not told otherwise. All right, now I've got 2 of these that are written in fractional notation, and now we see why it's of use to write it in fractional notation. What's the point? The point is this is pretty easy to do. I just add those exponents. 1/2 plus 2/3 is 3/6 plus 4/6, which makes 7/6. And now I have the answer in a much simpler format than it would have been if those were written as roots. Same here, when they're divided, I can subtract those. So 1/2 minus 1/4 just leaves me m to the 1/4, because 1/2 minus 1/4 is 1/4. And I can leave it like that, or if I'm in the mood, I can rewrite it as a 4th root. So there's the basics of the rules. Do your best, give it a try, ask Ms. Taylor questions when she comes back on Wednesday.